All right, this is lesson 8.2c, area of kites. And I can hear my kiddos are running up the stairs here, so we might get interrupted. All right, so here is a typical kite, and a kite has two pairs of congruent consecutive sides, which means these top two sides are touching, they're next to each other, and they're the same length. The bottom two sides are touching, they're next to each other, they're the same length as well, but these are different than the top two sides. Now, when we look at a kite, we cannot say base and height like we can on a rectangle or a triangle because we don't have a base, a bottom. But if I look at the diagonals, this vertical one kind of looks like how tall it is, and the horizontal one looks like how wide it is across the bottom. And so the diagonals are actually like the base and height. So this vertical one, I'm going to call diagonal number 1, which is like the height. And the other one, we're going to call diagonal number 2, which is like the base. And because I picked which one was going to be 1 and 2, we could interchange them, that the base is diagonal 1 and the height is diagonal 2. It doesn't matter which one is which. But for a kite, the formula for area is diagonal number 1 times diagonal number 2, and then divided by 2. And it's divided by 2 because this kite would fill up half of a rectangle if we were to surround it. Again, the diagonal 1 and 2 can be interchanged. It doesn't matter which one is which. So now what we're going to do is we're going to practice this on 2 different problems. So the first one here says find capital A, which means find the area. On a kite, it is symmetrical if you fold it hot dog style. So if we take the 2 sides of the kite and fold them together, they match up but perfectly. So this length of 3 here on the left would repeat on the right. However, that does not work when we fold the top part down because the top of the kite, those sides are shorter, so they wouldn't reach all the way down to the bottom of the kite. So looking at diagonal 1 versus diagonal 2, again, it doesn't matter which one is which. I'm going to call the height, the vertical one, diagonal number 1, and that would be 4 plus 8. So this would be a total length of 12 for diagonal number 1. And then for diagonal number 2, we're looking at the horizontal diagonal, or the width, or the base, I guess you could look at it. That would be 3 plus 3, so that would be a total length of 6. Okay, now it is a coincidence that 6 is half of 12. Doesn't always work that way. It is a coincidence that 4 is half of 8. Doesn't always work that way. All right, so to solve now, we're just going to plug it into the formula. Diagonal number 1 times diagonal number 2 divided by 2. And at this point, I would like you to pause the video and try this problem to see if you can get the correct answer. So pause it and try it on your own. See if you get the same result that I do. All right, so what I'm going to do is I'm going to replace D1 with the number 12. And I'm going to replace D2 with the number 6. And then divide by 2 is just part of the formula. And whatever that computes out to be, that's going to be the area of the kite. I'm going to grab my calculator. 12 times 6 divided by 2 comes out to be 36. I'm not sure if you can hear my kids in the background, but it sounds like they're a herd of elephants. All right, now if I look at the units up here, there's nothing labeled in the word part of the problem, but I do see this 3 inches as part of that diagonal length. So all of these lengths are inches, but because area is 2-dimensional, this would be inches squared. So our final answer here is 36 inches squared. All right, I'm going to close the door because they are being crazy. right, now in this next example, we are doing the same formula, but we are undoing the math. So we're going to plug in everything and then do a t-chart. So I'm going to set it up with the equation first. Area equals diagonal 1 times diagonal 2 divided by 2. Okay, now up here it says diagonal 1 equals blank, and they give us the vertical length of the kite. We just have to combine it together. So 5 and 10 make a total of 15, and because our area here is listed in inches squared, this would be 15 inches. Now diagonal 2 is not listed. That's this one here, and that's the one we're trying to find. So we're going to plug in all of our values and solve using a t-chart. Okay, so area, or capital A, is 45. So I'm going to put 45 here. D1, our diagonal number 1, was a length of 15. D2 is what's missing, so I'm going to leave that as D2. And then divide by 2 is part of the formula. And then I'm going to do a t-chart. So now you should pause your video, try these steps on your own, and then come back and check to see if you did it correctly. All right, so starting with my t-chart, I'm going to get rid of the division first. I'm going to multiply by 2 on both sides. The 2's on the right cancel. I have 15 times D2 left on the right. And then on the left, 45 times 2 is 90. And my next step would be to get rid of the 15. And because the 15 is being multiplied by D2, opposite of multiply is to divide. Fifteen's on the right would cancel. D2 would be left. And then I'm going to do 90 divided by 15 on my calculator, and I get a length of 6. Now thinking back about those units, the units for the area was inches squared. That meant the first diagonal was inches, and this second diagonal is also inches. All right, replay this if you need it. Ask me questions if you have any.